Alright, this is part 2 of number 27 on page 192. It's a linear programming problem. When I left off, I was debating down here where these two lines intersected. It's because I'm going to need that in order to try to determine my maximum or minimum. Actually, this isn't going to have a maximum because I could shade forever out this way, so there will be no maximum because this is an unbounded region. So I'm going to go ahead and check where these two lines intersect because it's really going to determine how many test points I'm going to have for my objective function chart. So I'm going to go ahead and take this, move it down here, and make it a system of linear equations. When I make it a system of linear equations, alright, we'll go ahead and draw those goofy little brackets. I can solve by using elimination. In order to solve by using elimination, I'm going to go ahead and multiply the top equation by -3. So I'm going to go ahead and show you how to do that. Multiply that top equation by -3. The reason why I'm multiplying it by -3 is so I can add the two equations later. After I multiply it by -3, I'm going to get an output here of 3x plus 6y equals 9. I can keep that bottom equation the same. I do like to write them right over top of each other. That does help me. Actually, it should be -3x, Mr. Claxon, plus -6y equals -9. You multiplied it by +3. Alright, but I did catch my mistake, so I'm just going to keep going on because I've redone this video now several times. I'm just going to go ahead and write the same equation right underneath. I'm going to then add the two equations. I'm using the elimination method here, so this is a little review for you. I eliminate the x variable. -6y plus 4y, I know is going to be -2y. And then I know that -9 plus 8 is going to give me -1. Divide by -2 on each side. Can't flip the sign here, it's an equals. It means the same thing. Y equals 1/2. Once I understand that y equals 1/2, I can back substitute it into, we'll go with that top equation over here. It was our original green equation. I didn't use green though, because I didn't want you to get this is an inequality. We turned it into an equality to solve. So I'm going to go ahead and back substitute it into that top one to find my x value. X plus 2 times 1/2 set equal to 3. I know that's going to be x plus 1 equals 3. And what number plus 1 is the same as 3? I know it's 2. So x equals 2. Could have also subtracted 1 on each side, but okay. So I know that it intersects at that point. So actually my graph up here it's kind of misleading because I really have 3 test points that I need to consider. I need to consider the top one, 0, 2. I need to consider where they intersect at 2 up 1/2. And then I need to consider where the magenta line right there, the pink line, I guess, intersects the x-axis. It intersects at 0, 3. A little bit easier to see. So now that I have those ordered pairs, those are my ordered pairs. Please excuse the sloppy handwriting. Now I can plug that back into my objective function. So we'll go ahead and start with 0, 2. And again, my objective function back at the top, it's where I'm getting this equation from. I know that x plus y is the same as that capital E. So I'm going to go ahead and add 0 plus 2. And what I'm using there is the x plus y. Set equal to E, so that would be a value of 2. In order to make that an ordered pair, I should put parentheses around it. I'm working too fast here. You might think I'm working slow. So then I said that we have 2 1/2. Understand, I solved it. Hopefully your graph was accurate enough to where you were able to just see it visually. I had to go back and solve for that. 2 1/2, obviously it's just going to be 2 plus a half. Everyone knows that's the same as 2.5. Whoa, something's happening here. Not quite sure what happened there. I'll undo that. I think I hit the mouse button. Getting a little shaky. That wasn't my hand. Not that nervous. And then I do have the point 30, which really doesn't matter because I know that I'm going to pick the minimum value, 3 plus 0. So my value there that I'm looking at is 3. I picked the minimum of all these values. You can see right here that the minimum is 2. So that would be our min. Okay, that's how you identify the minimum.